am going to discuss about allotropes of sulfur today. Clear? So, next, see how the sulfur is obtained. So, in the lower classes we have studied that sulfur is obtained by Frask process. Frask process. Remembering? Okay. So, what is happening in the Frask process? What they will do? The place in the earth where sulfur is available, at that place they will do 3 concentrated bore. They will do 3 bore in such a way these are the concentrated, means concentrating circle bores. So, they will do first bore, then in that second bore, then the third bore. So, 3 concentric circle type of bore is done. Then after doing that bore, what they will do, you know, from the outer circle they will put hot water. From the outer circle they will put hot water. From the inner circle they will put the hot air. So, when hot water is blown from the outer circle inside the earth where the sulfur is available, so due to the hot water, that sulfur will get melt, will convert into molten state due to the hot water. And after that hot water we are blowing the hot air. So, when hot air is blown to that molten sulfur, so pressure will be created below to the molten sulfur, so the sulfur will come top from this portion. So, from the inner circle, from the center circle, sulfur will be extracted. So, sulfur will be coming out from the inner circle. In this way sulfur is extracted from the earth crust, and this method is known as a Frask process. This we have done in the higher classes, lower classes. Clear? Higher classes is not possible, lower classes. So, Frask process, clear? What in the Frask process? They will do the 3 concentric circles. In outer circle they will enter the hot water. From the inner circle they will enter the hot air, and from the innermost circle liquid sulfur is obtained, molten sulfur is obtained. What is the role of each? Hot water when enters from the outer circle, it will go to the sulfur where the sulfur is present in the earth crust, and sulfur will get melt. Sulfur will get melt and it will remain in the earth crust. When hot air enters, so molten sulfur will exert a pressure. Due to the pressure, molten sulfur will come from the center hole. In this way sulfur is extracted from the earth crust, and this method was given by scientist Frask. That is why it is known as a Frask process. Clear? Now, there are number of allotropes form of a sulfur. Clear? There are number of colloidal sulfur, plastic sulfur, rhombic sulfur, monoclinic sulfur, many type of a sulfur are there, but the 2 most stable allotrope of a sulfur are 2, rhombic sulfur and monoclinic sulfur. Clear? So, when you read this some competition exam book, you will observe that there are number of allotropes of a sulfur, out of which 2 is most important. One is rhombic sulfur, another one is a monoclinic sulfur. So, rhombic sulfur is also known as a yellow sulfur because it is yellow in color. It is also known as a alpha sulfur, whereas monoclinic sulfur, it is a colorless sulfur and it is known as a beta sulfur. Clear? So, there are 2 most stable form of an allotrope of a sulfur, that is monoclinic sulfur and rhombic sulfur. Rhombic sulfur we say as a yellow sulfur because it is yellow in color, and it is also called as a alpha sulfur. Second type of a sulfur is a monoclinic sulfur, or we say as a beta sulfur. So, there are 2 most stable allotrope of a sulfur. One is rhombic sulfur, another one is a monoclinic sulfur. Clear? Next, we are discussing about the rhombic sulfur. So, how the rhombic sulfur is formed? See, when the solution of the rolled sulfur, so what will happen, you know, the sulfur which is obtained from the Frask process, they will get that sulfur, they will purify it and they will be converted into rolls. They will form on cooling, they will form the rolls. So, that type of a sulfur is known as a rolling sulfur. Clear? So, what you have to do, the sulfur which is obtained from the Frask process, which is cooled and converted into roll. So, that roll sulfur is evaporated, means it is heated in carbon disulfide solution. Okay, so that roll sulfur, it is evaporated in carbon disulfide solution. So, that solution on cooling will give the crystals, and that crystals are known as a rhombic sulfur. So how rhombic sulfur is formed? That when the rolled sulfur, when the solution of a rolled sulfur is heated or evaporated in carbon disulfide solution, on cooling the crystals are formed. That crystals is nothing but a rhombic sulfur. Clear? It will be yellow in color. Their melting point is 385.8 Kelvin and specific gravity is 2.06. Clear? So how the rhombic sulfur is formed? So rhombic sulfur is formed where? When the rolled sulfur, and I told you the story of rolled sulfur, the sulfur which is obtained from the flask process, that sulfur it is rolled on cooling, or after cooling it is rolled. So that type of a sulfur we say as a rolled sulfur. This rolled sulfur it is heated in the presence of a carbon disulfide or evaporated. The evaporation causes on cooling, that evaporated on cooling will form a crystals, and that crystals we say as a rhombic sulfur. Its melting, it is yellow in color, so this is very important, that's why it is also known as a yellow sulfur. Its melting point is 385.8 Kelvin and specific gravity is 2.06. It is insoluble in water. Oh, rhombic sulfur. So it is insoluble in water but soluble in carbon disulfide. So this rhombic sulfur is insoluble in water but soluble in carbon disulfide, benzene, ether like a solution. So please remember that rhombic sulfur is insoluble in water, and whenever anything is insoluble in water, it will be soluble in a non-polar solvent like carbon disulfide, benzene, ether, etc., alcohol. Next we have a monoclinic sulfur. So how to form a monoclinic sulfur? You have to take the rhombic sulfur and you have to heat in a china dish. Okay, just you take a rhombic sulfur and you heat the rhombic sulfur in a china dish at temperature nearly 369 Kelvin. So you will obtain the crystals. So that crystals are nothing but a monoclinic sulfur. How to form the rhombic sulfur? To form the rhombic sulfur, you have to take a rolled sulfur and you have to evaporate in a china, and you have to evaporate in a solution of a carbon disulfide. On cooling, we get a yellow color crystals. So that yellow color crystals are known as rhombic sulfur. How to obtain the monoclinic sulfur? So monoclinic sulfur is obtained by heating the rhombic sulfur. So rhombic sulfur is heated in a china dish on cooling, on china dish. So on cooling it will form a crystals. That crystals are known as a monoclinic sulfur. So on that crystals, what we are doing, on that crystals we will do two holes, and when we do the holes and when you shake it, so from that holes remaining molten sulfur will come out. So that molten, after removing the molten sulfur, you will obtain a very good crystal of colorless. So that good crystal of colorless is known as a monoclinic sulfur. So see, melting rhombic sulfur in a china dish, on cooling crystals are formed. So melting the rhombic sulfur in china dish, then on cooling crystals are formed, and that crystals is known as a monoclinic sulfur. But on that crystals now number of holes are made to remove the molten sulfur which is present inside it. So then holes are made and remaining liquid sulfur is poured. Then the crystals of colorless are formed, which is known as a beta sulfur or monoclinic sulfur. So after the cooling the crystals, the holes are made, and from that holes the liquid sulfur is removed. So that liquid sulfur is removed, then we obtain the colorless one crystal. That colorless crystal is known as a monoclinic sulfur or beta sulfur. Clear? So these are the best these are the good topic of rhombic sulfur and monoclinic sulfur. They can ask you the difference also. Clear? Other things I have not written here. What it is boiling point and melting point you can write down. Okay. Now most important topic I am going to discuss is transition temperature. This is most important topic of today, that is the transition temperature. What do you mean by transition temperature? And it is the topic related to this allotrope of a sulfur. So once more I will repeat, there are two kind of allotrope of a sulfur. One is rhombic sulfur, another one is a monoclinic sulfur. Rhombic sulfur or yellow sulfur which has alpha sulfur, monoclinic sulfur means beta sulfur. We are obtaining the sulfur naturally from the earth crust using the flask process, and on cooling we obtain the rolls. So that is known as a roll sulfur. When the roll sulfur is evaporated or heated in the solution of a carbon disulfide, on cooling the crystals are formed, and that crystals will be yellow color, and that we say as a rhombic sulfur. Okay. That rhombic sulfur is soluble in water but insoluble in water, but soluble in carbon disulfide, benzene, alcohol, ether. Monoclinic sulfur, how we are obtaining the monoclinic sulfur? So we are taking the rhombic sulfur and we are heating in the china dish at nearly temperature 369 Kelvin. So on cooling crystals are formed. That crystals, in that crystals holes are made. In that holes remaining which is molten sulfur, which is not formed, molten sulfur which is removed, and we get one colorless crystal, and that colorless crystals is known as a monoclinic sulfur or beta sulfur. Clear? The crystals of a colorless beta sulfur is formed. Now we are having transition temperature. See what do you mean by transition temperature? If you take a rhombic sulfur, and when you heat the rhombic sulfur above 369 Kelvin, you obtain the monoclinic sulfur. Means rhombic sulfur is unstable at temperature above 369, because rhombic sulfur above 369 Kelvin, it is converting into monoclinic sulfur. Yes or no? So rhombic sulfur, when you are heating the temperature above 369 Kelvin, it is converting into monoclinic sulfur. That indicates what? That rhombic sulfur cannot exist the temperature above 369 Kelvin. Means rhombic sulfur is unstable above the temperature 369 Kelvin. Means if I want the rhombic sulfur is stable only at the temperature below 369 Kelvin. Clear? See, understand once more. Rhombic sulfur when heated at the temperature 369 Kelvin above, so it will convert into monoclinic sulfur. Means rhombic sulfur is unstable at temperature above 369 because it is converting into monoclinic sulfur. So rhombic sulfur is unstable the temperature above 369 Kelvin, but stable at the temperature below 369 Kelvin. So rhombic sulfur, I can add here rhombic sulfur is stable below 369, stable at 369 or below, 369 or below, yes or no, or below. Who? Rhombic sulfur, because it is not greater than or equal to, it is greater than 369. Means rhombic sulfur can exist at the temperature below 369 or at the max 369. Similarly, monoclinic sulfur is unstable at the temperature lower than 369. The monoclinic sulfur is only stable at the temperature 369 or above. Yes or no? So monoclinic sulfur is formed at the temperature above 369. I can say that monoclinic sulfur is unstable at the temperature below 369. Yes or no? So monoclinic sulfur is stable at the temperature 369 or above it. So I can write down like this also, monoclinic sulfur is stable at 369 or above. Means at 369 both the allotrope form are stable. See, as I written now, rhombic sulfur is stable at 369 or below. So rhombic sulfur can be only stable, can only exist at the temperature 369 or below it. Similarly, monoclinic sulfur is stable or will exist at the temperature 369 or above it. Means rhombic sulfur and monoclinic sulfur both are stable at the temperature 369. So these two allotropes of sulfur, they are stable at some temperature. The temperature is 369. So that temperature we say as a transition temperature. So what do you mean by transition temperature? The temperature at which both the allotropes form of a sulfur are stable. So that type of a temperature we say as a transition temperature. And what is the transition temperature for the allotrope of a sulfur? 369 Kelvin. So you write down this. This you can copy out by taking the screenshot, but you can write down this transition temperature. Write down this transition temperature, please. Write down. Monoclinic sulfur is stable at temperature. Monoclinic sulfur is stable at temperature higher than 369 Kelvin. Higher than 369 Kelvin. But changes to rhombic sulfur. At temperature below than 369 Kelvin. At the temperature below than 369 Kelvin. On other hand, rhombic sulfur is stable at temperature below 369 Kelvin. On the other hand, rhombic sulfur is stable at the temperature below 369 Kelvin, but changes to monoclinic sulfur above it. But changes to monoclinic sulfur, the temperature above it. Thus, at the temperature 369 Kelvin, both the allotrope form of sulfur, thus at the temperature above 369 Kelvin, both the allotrope form of a sulfur are stable. Thus at 369 Kelvin, both the allotrope form of a sulfur are stable, which is called as transition temperature. which is called as transition temperature. You can write down this. Now you write down this. Please write down this. This reaction is very important. Transition temperature. Clear? Written? Write down one. Monoclinic sulfur is also known as a prismatic sulfur. Monoclinic sulfur is also known as a prismatic sulfur. Okay. Now see here. See, sulfur can form two kind of a ring structure, either S8 or S6. So S8 is a crown shape puckered ring. Puckered ring means closed ring, crown shape. So we say as a crown shape conformer, and this we say as a chair shape. Chair shape. Okay. See here now. So how the crown shape is there? This is crown shape. You can see A set 1, 2, 3, 4, 5, 6, 7, 8. So this is A set, puckered ring shape. Okay. We say chair shape, chair conformer. Okay. So this is S8 ring and this is S6 shape. So this is crown shape and this is chair shape. Clear this part? Write down next. Several other modification of sulfur molecule can be done by the formula Sn. Several other modification of the formula of sulfur molecule can be done by the formula Sn, where n is equal to 6 to 20. Write down. This is very important MCQ. So molecular formula of sulfur is Sn, in which n contains nearly 6 to 18. Clear this part? So you can remember this n. This SS structure formula is nearly Sn. Sulfur molecular formula is Sn, and in which n contains nearly how much? 6 to 18. So today I will keep this much only. See, please remember this transition temperature. This transition temperature is very important because it will help you in many MCQs. And remember this, most important is you remember this value, that is 369 Kelvin, rhombic sulfur, monoclinic sulfur. See, we have number of allotropes of a sulfur, okay. The most stable allotrope is only rhombic and monoclinic. There are several other allotropes of a sulfur also, like you can take monoclinic, rhombic, colloidal sulfur, plastic sulfur, delta sulfur, many are there. But it is given in your textbook only two, that is rhombic sulfur and monoclinic sulfur. It will come in the exam also from these two only. When you are reading some other certain books of competition, you can see other type of a sulfur. So need not to worry about it. You study this in these two in detail. You study, you can get the more marks. See, last point also very important, which I have written, that is monoclinic sulfur is also known as a prismatic sulfur. So this also you have to remember. So have a nice day. Thank you. Next class I will go with the sulfur dioxide, and then I will move with the very important topic, contact process of sulfuric acid. Thank you.